Hello everyone, welcome to another IGCSE Mathematics tutorial. Make sure to like, subscribe, comment any questions you may have or any feedback you may have, and check out our channel for previous videos and upcoming videos. Today we'll be discussing sequences. First, we'll talk about arithmetic sequences. Let's take a look at the sequence 4, 9, 14, 19, and 24. You will notice that to get to the next term, we add 5 to the previous one. So 4 plus 5 is 9, 9 plus 5 is 14, and so on. Let's look at another sequence, 21, 17, 13, 9, and 5. This time, we're subtracting 4 to get to the next term. 21 minus 4 is 17, 17 minus 4 is 13, and so on. These two sequences are examples of arithmetic sequences. Sequences where we add or subtract a certain number each time. The amount we add or subtract is called the common difference. So in the first one, the common difference would be 5 since we're adding 5. In the second one, the common difference would be minus 4 since we're subtracting 4. Include the signs. That is very important and it's a mistake a lot of people make. Make sure that you include the signs always. Let's move on to geometric sequences. Let's look at a third sequence. 2, 4, 8, 16, and 32. You'll notice that the numbers are being multiplied by 2 each time. So 2 multiplied by 2 is 4, 4 multiplied by 2 is 8, and so on. Let's look at another sequence. 81, 27, 9, 3, and 1. This time, we're dividing by 3. These two sequences are examples of geometric sequences. A sequence where instead of adding or subtracting a common difference, we multiply by a certain number. This number is called the common ratio. So in the first one, the common ratio would be 2, since we're multiplying by 2. In the second one, we're dividing by 3. Instead of the common ratio being 3 or minus 3, it should be 1 over 3, since 1 over 3 is the same as dividing by 3. There are other types of sequences that you need to be aware of. When answering questions, you'll be asked questions on the two types of linear sequences we've discussed already, arithmetic and geometric sequences, as well as other types of sequences. First, quadratic sequences. For example, the second term might be the first term squared, or the second term might be the first one squared plus an extra constant, 1 maybe. Cubic sequences. The second term might be the first term cubed, or again cubed plus 1. It's another example. Or exponential sequences. For example, 2 to the power of n, where n is the number of the term. So the first term would be 2 to the power of 1, or just 2. The second term would be 2 to the power of 2, or 4. 2 to the power of 3, which is 8, and so on and so forth. You will also be asked questions on simple combinations of any of the above sequences, as well as the two linear types. Make sure to get a lot of practice answering questions to get familiar with patterns between questions and the interactions between the different types of sequences. Let's talk about sequence notation. Often, questions will use specific notation when talking about sequences and certain terms within those sequences. A sequence is often referred to with the letter T. For example, the first sequence we discussed can be written as T equals 4, 9, 14, and 19. The sequence itself is referred to as T. In the above sequence, we can also use subscript notation to refer to specific terms in the sequence. So, T subscript 1 would be the first term of the sequence, or 4. T subscript 2 is 9, the second term. T subscript 3 is 14, and so on. Let's talk about the nth term of a sequence. Questions will often ask you to find the nth term of an arithmetic sequence. The nth term of a sequence refers to the term in that position. So if n equals to 10, it's the 10th term of a sequence. If n is 25, it's the 25th term. If it's 13, it's the 13th term, and so on and so forth. To find the nth term of a sequence, first you must find the expression of the sequence from the given terms. You will already be given terms. So for example, our previous sequences, we had the 5 first terms. In the exams, you will get the similar number of terms and you can use those to find the expression. You can then plug your n value into the expression that you found to find the number that they want. Let's continue. To find the expression of a sequence, first you must find the common difference. Once again, we're talking about arithmetic sequences here, so it's a common difference. Let's use our previous example. T equals 4, 9, 14, 19, and 24. We already know that the common difference here is 5. We've discussed that previously. The next step is to multiply our common difference by n. In this case, just any n, and our common difference is 5, so we get 5n. That is the first part of our expression. The next step is to find out if we need to add or subtract any number to get 5n, to get to our sequence. To do this, we imagine that there is a term before the first term. The first term is 4, we imagine that there is a term before it. We call this term t subscript 0. To find this term, we can subtract our common difference from the first term to get minus 1. So 4 minus 5 is minus 1. We include this value in our expression to get 5n minus 1. This is our final expression, and we can use this to find the nth term. For example, if we want the 10th term, it would be 5 multiplied by 10, since n is 10, minus 1, so 49, so on. Make sure, this is very important, you are subtracting the common difference. So if the common difference is already a negative number, like in our second example earlier, the common difference was minus 4. If you are subtracting minus 4, it would be minus 4 or plus 4. Keep that in mind, that is very important. You can double check if the expression works before using it to find the nth term by trying it for one of the given terms. So one of our given terms here is 14, it's the third term. 5 times 3 is 15, minus 1 is 14, therefore we know it works. Thank you for watching. Once again, make sure to like the video, subscribe to the channel, comment any feedback or questions you may have, and check out the channel for our previous and upcoming lectures.